Hello. How are you? Hope you're doing well. Today is another lesson where we are learning about the application of trigonometry. Remember, in our previous lesson, we have learned about the foundation or the basis of trigonometry. In that foundation, we have understood what is the origin or where is the origin of trigonometry, right from Pythagoras theorem all the way to trigonometric ratios. And today, I want us to apply trigonometry. So in this case, the application of trigonometry will always take shape in different aspects of activities that happens in our life, from structures, from every aspect that we interact with in our lives. Perhaps, or in most cases, mathematics will always be included. But in this case, now I want us to focus on the application of trigonometry. Now, in this case, we have a question here. A flagpost 10-meter long is fixed on top of a tower. Flagpost 10-meter long is fixed on top of a tower. Flagpost 10-meter long is fixed on top of a tower. In this case, we are talking about a tower, and on top of that tower, we have a flag post. Then from there, we are told from a point on a horizontal ground, from a point on a horizontal ground, the angles of elevation to the top, and bottom of the flag post are as follows: 40 degrees, then 33 degrees respectively. Respectively. Calculate A, the height of the tower. Then B, calculate the shortest distance from the point on the ground to the top of the flag post. The shortest distance from a point on the ground to the top of a flag post. In this case, you understand that you must be able to understand the key areas. You must be able to pinpoint the key areas or the key parts of this question so that you can be able to interpret it properly. Number one, you must understand that in this question, there is something called a flag post, which is on top of a tower. So you have to understand that this is the basic important part of this question. The flag post that is on top of a tower. Then from there, you are able to understand that the angle of elevation is to the top of the flag post and to the bottom of the flag post, not the tower. To the top of the flag post and the bottom of the flag post. So let us solve this question. Please make sure that you have copied this question as we start solving this problem. Now, allow me a rabbit so that we can solve it together. Let me rub it so that we can solve together. And in this case, you have to be able to understand the problem and the key areas that you're supposed to focus on. So number one, we must have a flag post. Number two, we must have a tower. We must have a flag post and a tower. So in this case, allow me draw my flag here. Then a tower. This is the bottom of the tower. Then there's a point on a horizontal ground. Let's call this point the point of observation. Now, this is a point on a horizontal ground. Then we are talking about the top of the flag post and the bottom of the flag post. So we are talking about the top of the flag post and the bottom of the flag post. Remember, we are not moving from this point. We are just using this point X, and we can call this one Y here. This point X here is the point of observation. We are elevating. The point of elevation. This is elevation. This is depression. Remember, In our last class, we learned about elevation and depression. So in this case, we are talking about elevation. We are told that the flag post is 10 meter long. The flag post is 10 meter long. The flag post is 10 meter long here, talking about 10 meters. And then the height of the tower, or the tower is not given at the height, but we have the angles of elevation. We have the angles of elevation. The angle of elevation to the top of the tower is 40 degrees. The angle of elevation to the top of the tower is 40 degrees. And the angle of depression, the angle of elevation to the bottom of the flag post. The angle of elevation to the flag post is 40. The angle of elevation to the bottom, this 40 is to the top, 30 degree is the bottom. So this one is the 33 degrees. 33 degrees. 33 degrees. So in this case, you have to be very, very, very careful when you are interpreting. So this one is 33 degrees and the other one is 40 degrees. Now, how do we get the value of the height? Number one, you have to remember the trigonometric ratios. The trigonometric ratios where we talked about SOHCAHTOA. And in the SOHCAHTOA, we have to look for a ratio. You have to look for a ratio that is relating properly with the question. So in this case, if the angle is at this point, this one will be treated as the opposite, this one will be the adjacent, and this one will be the hypotenuse. Now, what is our point of interest? Our point of interest in this question is the height. The point of interest in this question is the height. So if we use 33 degrees, remember, we will be using the opposite as the height here. But if we use 40 degrees, the angle of elevation to the top, it means that we are going to be using 10 and h as the total height of that, of the whole height from the bottom of the tower to the top of the flag post. So if we talk about tan 33 degrees. When we say tan 33 degrees, we know that tan is given by opposite over adjacent. So in this case, the opposite is height and the adjacent is xy. The adjacent is xy, but instead of xy, let me just call it let's use it as the A or letter A to represent the adjacent. So in this case, we are going to have tan 33 is going to be given by height over the height of the tower all over this adjacent here. So we call A to represent adjacent. The other part that you are supposed to observe is when we talk about tan 40 degrees, when we talk about tan 40 degrees, the opposite of tan 40, this is the whole angle. That degree plus some other 7 degrees to make it 40 degrees. The whole angle here, the angle of elevation to the top of the flag post, inclusivity of height and 10 meter. So in this case, you're going to say that tan 40 is going to be given by opposite, which is 10 plus h all over adjacent. It is 10 plus h, which is representing height all over adjacent. It is tan 40, which is 10 plus height all over adjacent, which is unknown. And we must first of all get either of them. We either choose to get height or we either choose to get adjacent. We either choose to get height or we either choose to get the adjacent. So in this case, allow me choose to get the height. So in this case, how can I get the height? In this case, when we use the first equation, we must make height the subject of the formula. When we use also the second equation, we must make height the subject of the formula. So how do we make height the subject of the formula? So in this case, we are going to multiply both sides by a and both sides by a here. In this case, we are going to have a tan 33 degrees equals to height. Tan 33 degrees multiplied by a is going to be equals to height. In the second equation, we must make height the subject of the formula. So first of all, we eliminate the denominator. Eliminating the denominator so that we can make height the subject of the formula, we must multiply both sides by a. So if we multiply both sides by a, You multiply by A, you multiply by A. So we're going to have A tan 40 degrees equals to 10 plus H. A tan 40 degrees equals to 10 plus H. Then from here, we are going to make height the subject of the formula by bringing like terms together. So in this case, 10 is going to be taken to the other side, where we are going to have A tan 40 degrees equals to 40 degrees minus 10 meters equals to height. So these two ratios, equation 1 and equation 2, both of them when solved are going to give us the value of height. Both of them solved are going to give us the value of height. So there is no mistake we can commit here by equating both of them, because if we equate both of them, it means we are going to get the same value, which is height, and which is the subject of the interest. So our interest here, so in this case we are going to have A tan 33 degrees should be equals to A tan 40 degrees minus 10 meter. A tan 33 degrees should be equals to A tan 40 degrees minus 10 meter. A tan 33 degrees minus equals to A tan 40 degrees minus 10 should give us the same value. So in this case, if we get the value of tan 33, when we get the value of tan 33, we are going to have 0. The value of tan 33 is going to be 0.6494. Please confirm from your calculator. Should be equals to 0.6494. A should be equals to 0.8391 A minus 10. So in this case, I have obtained the value of tan 40 and obtained the value of tan 33, so that we can have something that is mathematical in a way. I hope all of you can see that the question is taking a proper shape. So in this case, we must again bring like terms together to the same side. So if we have to take 0.8391 to the other side so that both A's can be at the same side, we are going to have something like this. This one comes to the other side here. So we are going to have 0.6494A minus 0.8391A should be equals to minus 10. Getting the difference. The difference here we are going to have negative. Remember, 0.6494 is less than 0.8391. So in this case, we're going to get our answer, or the value of A in the left side, as negative. So in this case, you're going to have negative 1894, negative 1894A should be equals to negative 10. Then from there, remember we are solving the value of A. When we divide, remember we are supposed to divide here now. So allow me Rab to create more space. So that we can create more space. So in this case, we are going to have something like this: negative 1.1894A equals to minus 10. You divide by negative 1894 divided by negative 1894. Remember, this one was 10. So in this case, the value of A is going to be 52. The value of A is going to be 52.71. The value of A is going to be 52.71. Now, 52.71 is the value of A, and A was standing for the adjacent. So, if we try to resketch again our original structure. our original structure, if we try to sketch here, we are going to have something like this. Now, it has taken shape. This one becomes 52.71. This one is height, and this one is 10. That one is 10. Now that we have obtained the value of the adjacent, we can use 33 degrees with its tan, or we can use one of the ratios that we expressed. Remember, we made two ratios at first so that we can make h the subject of the formula. So here we had 40 degrees. Here we had 40 degrees. So again, allow me wrap this part so that we can use the space well. So we will have the first equation was tan 33 degrees was supposed to be given by height, which is the opposite, over adjacent, which is 52.71. Now, tan 33, if you want to get height, so height is given by tan 33 multiplied by 52.71. That is what we agreed. We agreed that tan is going to be given by tan 33 multiplied by a. And a has its value as 52.71. When we get that value of tan 33 multiplied by 52.71, our height is going to be 34.23. Our height is going to be 34.23. I hope you are following. I hope you have been able to see how we have obtained the value of height for equation A or for equation R. Then we are going to question B. So that we can give justice to the question as it should be. Now, for question B, the question was, find the shortest distance from the point on the ground to the top of the flag post. The shortest distance, this was X, this was Y, from the point on the ground to the top of the flag post. So in this case, we have to use Pythagoras theorem. Remember, we now have the value of height here as 34.23. We have the value of height here as 34.23. So in this case, for solution in B, we are going to have the Pythagoras theorem that says that a squared plus b squared equals to c squared. A squared plus b squared equals to c squared. What is A? The value of A here will be 52.71. Then the value of B will be 34.23. That 4.23 plus 10, which is going to be this 34, which is going to be 44.23. 44.23, so that we can obtain the value of C. I hope we are all sailing together. So in this case, we're going to have A squared, which is 52.71 squared, plus B squared, which is 44.23, should give us C squared. When we get the sum here, if you calculate here, we are going to have 4734 or 4734.63 should be equals to C squared. But we want the value of C. So when our problem is in form of 4734.63 equals to C squared, we get the square root from both sides. The square root of C squared will be C, and then the square root of 4734.63 will be 68.81. So the value of C is 68.81 meter, or the value of the hypotenuse is 68.81 meter. I hope you have been able to follow. Despite the challenge with this imported pen. Despite these challenges with these imported pens, I hope you have been able to follow. Now, when you follow, the major problem in this equation is being able to create the problem of making height the subject of the formula and understanding that both the ratios as we have expressed them are going to give us height. After getting that, you are able to equate them to get the value of adjacent. When you equate them, you are able to get the value of the adjacent. After having the value of the adjacent, the problem becomes easier, like drinking water, because you already have the adjacent. When you have the adjacent, it is easy because you are going to replace the other one to obtain. You just find the suitable ratio. And in this case, remember, initially we chose to use tan. So you still use tan so that you can be able to obtain the value. Then for B, that one is simple because you know that from the foundation of trigonometry, we all started from Pythagoras theorem. We all started from Pythagoras theorem. So when you relate with Pythagoras theorem, you are able to get the value of the hypotenuse. You are able to get the value of the hypotenuse. You are able to get the value of the hypotenuse. I don't know whether my tools here will allow. Don't know whether my tools here will allow. But let us try to look at another example. Let us try to look at another example here. Same application of trigonometry. Same application of trigonometry. I have scribbled down because the size of my board is so big to accommodate statements. My size or my board size is so big to accommodate statement. So allow me first of all analyze a statement from a scribbled section so that we can interpret it here using the board. From a watchtower, listen, from a watchtower, the angle of depression of both A is 30 degrees. From a watchtower, we have something called watchtower. Have a watchtower. We are told the angle of depression is 30 degrees to both A. The angle of depression to both A is 30 degrees. And the angle of depression of both B. The angle of depression of both B. From where? From the watchtower. So from the watchtower, the angle of depression of both A is 30 degrees. The angle of depression of both B, this is both A, then we have depression 45 degrees to both B. We're talking about both A and both B. So the angle of depression to both B, is 45 degrees. The two boats are 20 meters apart. The two boats are 20 meters apart. The two boats are 20 meters apart. I hope everyone is able to create an impression where we are talking about a watchtower. From a watchtower, there is an angle of depression. An angle of depression from a boat A. Then boat B. There is angle 30 degrees to boat A, and there is angle 45 degrees to boat B. Then from there, we are told that both A and both B are 20 meters apart. We are told that both A and both B are 20 meters apart. Remember, it is not from the foot of the tower, but from boat A to boat B is where we have 20 meters apart. So let us sketch the diagram, or let us diagrammatically interpret the question so that we can be able to solve. Remember, in trigonometry, interpretation is the basic and the most important aspect of trigonometry. If you are unable to interpret the question properly, I promise you, you will not be able to score it properly or to score it correct. But if you first of all try to break the statement down so that you can understand, you'll be able to solve. You'll be able to solve. What do I mean? Let us interpret. So we have a watchtower here. So it means the tower must not be a dot, of course. It must be something strong. So let us create a tower here. Then there's a point here. Let's call the tip or the top of the watchtower here the point of observation. Let us call it the point of observation here. Then we have about A. We have about A. We agree that this one is the ocean, because the boats must be in the lakes or the ocean. So perhaps this is the ocean or is the lake. So this one is our lake here. Then we have boat A here, boat A here. Then we have boat B, boat B. You have to pardon my drawing. We have boat A and boat B, boat A and boat B. What are we told? The angles of depression. The angle of depression to boat A is 30 degrees, and the angle of depression to boat B is 45 degrees. The angle of depression to boat A is 30 degrees, and the angle of depression to boat B is 45 degrees. Then from there, we are also told that the two boats are 20 meters apart. The two boats are 20 meters apart. The two boats are 20 meters apart. So this is the foot of the tower. That is the foot of the tower. This is the foot of the tower. This is boat A. This is boat B. So what's the question? The question asks, calculate the height of the watchtower. Calculate the height of the watchtower. Calculate the height of the watchtower. That is the first one. Calculate the height of the watchtower. This question is more or less the other one that we did, so that I have just chosen to redo it so that you can understand. But a different example in a different way. We're talking about a watchtower. Then we are talking about boat A, or two boats, A and B, 20 meters apart. So in this case, if we want to obtain the height of the tower, where is the height? Here. Which angle? 30. This is an adjacent of 30 degrees. And this one is the opposite. So we can call this opposite as FA. FA, that is FA, meaning from the foot of the tower to A, or let's just call it X. Let's just call it X. Let's just call it X here. So to use or to get the height here, we can talk of tan 30 degrees should be equals to opposite, which is X over adjacent. X over H, which represent adjacent. This is the first ratio. The first ratio, or the first equation. Then we can also say that tan we can also say that tan 45 degrees will be given by opposite, which means now it is this one And the opposite of this one, the opposite of the whole of this angle is the whole of this base here, or the whole of the from the foot of the mountain to both B, which is x, which is x, which is x, which is x plus 20. Now, guys, because my tools are kind of misbehaving, allow me solve this one in the next lesson. I hope you have followed well. I hope you have followed well and you have understood. And I hope as I come, because this one, the opposite of this one is x plus 20. The opposite of this one is x plus 20. Yeah, I don't know whether x plus 20. And the adjacent is height. I hope you can be able to use this ratio and the other one here so that you can be able to solve. So let us meet in the next lesson as we try to get the values of the height and x, which means from the foot of the mountain, or I mean of the watchtower to boat A, and from the foot of the watchtower to boat B. You can also use it as a challenge where you try to use these two ratios to get the values before we meet in the next lesson. Otherwise, stay tuned, subscribe for more, as we'll be keeping you updated with all lessons and all areas that you feel you have a problem, right from mathematics to other subjects as we go on, because we mind about you and we want you to be the best of yourself. Thank you very much.